We don't notice it's even there, but it's all around us. It's in our environment, it's in our water, it's in our homes, our streets, and our food. It is at the center of new technology, new forms of energy, new ways to fight disease, and new ways to solve the problems we all face together. It is every day, and it is life-changing. It is the future. Often we don't notice it's even there, but it's all around us. It's in our environment, it's in our water. It's new forms of energy, new ways to fight disease, and new life-changing. It is the future. But it's all around us. It's in our environment, our water. It's in our home. energy.
Hello. Yes, we are starting it today a little earlier, right? And then I mentioned this. How are the things? I hope you can hear me. Everything. Good evening, all of you. Can you hear me well? Yes, right. Very good. Very good. I hope everybody can hear me well. Right. Because it's the last few days of the month also, no? So the kind of also running low sometimes. So might be not be able to hear. Don't know. So we'll start with this tutorial. Huh? Tutorial number 2, chemical calculations, tutorial number 2. Do you have the tutorial with you? Let us start. Right, let us start. Let us work on it. I have seen that a lot of children suggested that we need to discuss this quickly because there are some difficult questions, it seems. Right. Okay. So if you look at the page number 1, I have mentioned the theory in the summarized form. This is your summary, right? This is your summary that you have, right? Clear? Did you understand that? That is the summary that you have. And then on the second page also, you whatever the things that we have written in the note, I have summarized it into a kind of a very few lines here, right? Page number 3 also like that. And then the tutorial, actually the work sheet begins from page number 4. So I will straight away go to the page number 4. And then the first page that you have is this, right? Relationship of moles per cubic decimeter and ppm, right? How do you convert moles per cubic decimeter into ppm? Let us say now there's a box that is given. I want you to kind of write it down properly. Yeah. So let us say you have a concentration C and you want to convert. Now this is given in moles per cubic decimeter. Moles per cubic decimeter. Let us convert it to ppm, parts per million. If the concentration is given moles per cubic decimeter, this is how you do this. You have to convert it to milligrams per cubic decimeter. So ppm means for dilute solution, it is milligrams per liter. Liter means cubic decimeter. So you don't have to convert the cubic decimeter, but moles you have to convert it to cubic milligrams. How do you do that? So what you do is you can take the concentration multiplied by the molecular mass or the atomic mass. So I will write this as molecular mass. Convert it to milligrams. How do you convert it to milligrams? Multiplying by 1000. This is the basic way of calculating this, right? This is how you convert the concentration into ppm. If there is mass fraction, you multiply by what? Can you tell me? Multiply by 10 to the power 6. That is ppm, right? If you have the volume fraction, you calculate, convert it to ppm by multiplying by 10 to the power 6. That's all. Now, these are the 3 methods that you can convert this thing, right? Right. Right. Okay. So now let us look at starting with the first one. It says, right, a mixture of KOH and calcium hydroxide contains 0.2 moles. Calculate the moles of calcium hydroxide in its mass fraction, right? So you have potassium hydroxide. What else? You have calcium hydroxide. No, these are the two materials you have. And it says 0.2 moles calcium hydroxide. Potassium hydroxide 0.2 moles, right? 0.2 moles of potassium hydroxide. And the mass of the mixture is 26, right? Mass of the mixture is 26 grams. It total mass is 6. the mass of calcium. How do you do that? Let's see how to do this one. Let's calculate potassium hydroxide. Tell me how do you mass potassium hydroxide is equal to number of moles times mass. Number of moles is 0.2. Tell me the number. Tagal again. Potassium 39, oxygen is 16, and this is 1. What is the molecular mass? Molecular mass is, what is the molecular mass there? Can you suggest the molecular mass? 56. 56 molecular mass is 56 grams per moles. So now you know the total mass. What is that? 0.2 times 56 is equal to 11.2. Balanda, do the calculation and work with me. Then you can calculate the mass of calcium hydroxide. So what is the mass of calcium hydroxide? Mass of calcium hydroxide, how do you get that mass? Can you all tell me? I'm sure you have done it now. How do you calculate the mass of calcium hydroxide? What is the method? Total mass is 26. 11.2 is potassium hydroxide. So subtract. So 26 minus 11.2 grams. Can you tell me what is the value? Subtract 26 minus 11.2. What is that? 14.8. 14.8 grams. What do they ask? They ask you to calculate the moles of calcium hydroxide and, and its mass fraction. Let us look at the moles of calcium hydroxide. What is the number of moles of calcium hydroxide? How do you calculate that? How do you calculate that? Mass divided by molecular mass. What is the mass? Is 17 plus 1, 18. What is the molecular mass that you get? Calcium hydroxide molecular mass. Molecular mass, calcium hydroxide molecular mass. What is the molecular mass that you get? 70, 74 to 76th. Double check. There are answers saying 74, but what I got was 76. Others? 74. Really? Oxygen is 16, hydrogen is 1, 17 times 2, 34 plus 40. Yes, 74. Yeah, you are right. 74 grams per moles. Right. So what is the answer? 14.8 divided by 74 is equal to, what did you get? 0.2 moles. Did you understand that? That is the number of moles of calcium hydroxide. That is the number of moles of calcium hydroxide. Now what they ask is, what is the mass fraction of calcium hydroxide? Mass fraction. What is the mass fraction? Divide by the total mass. What is the answer? 14.8 is the calcium hydroxide mass. What is the total mass? Total mass is 26 grams. 26 grams. So what is that? 14.8 divided by 26. What is the answer? What is the answer? 13. 14.6 divided by 14.8. You can put this into a decimal form rather than keeping it in a weird fraction. Fraction, mass fraction cannot be greater than 1. Mass fraction cannot be greater than 1. What should be the answer? Yes, 69. At least you can say 0.57. Did you get that answer, Puta? Everybody? Did you understand it and get the answer? we give the mass fraction, you have a kind of a very weird fraction. It's a weird fraction. So best thing is to convert this. If you 2 divide by 5, that is okay. 100 put this and do it. Yeah? Is it clear? Your voice is lagging here, එහෙම ප්‍රශ්නයක් තියෙනවද? Really? Running out of choices. No. Is there experience in that? Let me continuous lagging. Okay. Maybe because I'll will double check. See whether now we are okay. How about now? Is it all right or now better? Okay. Let's see whether we can work like this. Right. So this is the question number 1. This is question number 1 here under chemical calculations. Question number 1 is that. Okay. Shall we try question number 2? Right. Let us read the question. See whether we can understand that. A mixture contains 0.0 moles of sodium hydroxide. 0.04 moles of sodium hydroxide. There is sodium hydroxide, 0.04 moles. I will draw this so that you all can visualize it. 0.04 moles of sodium hydroxide. And inside this you have magnesium. Magnesium, 0.05 moles of magnesium. Determine the mass fraction of sodium hydroxide and its ppm value. So you need to convert it to mass. How do you convert it to mass? So let us say mass of sodium hydroxide, always equation, substitution with units and the answer, right? Where steps to always try to use that. 0.04 moles, right? Mass, molecular mass is 40 grams per moles. So what is that? You get 1.6 there. 0.04 times 40 is equal to 1.6 grams. Sodium hydroxide mass is 1.6 grams. What is the mass of magnesium? Mass of magnesium, how much is that? 0.05 times moles times molecular mass. 24 grams per moles. So moles per moles, 0.05 times 24. 0.05 times 24 is equal to 1.2 grams. Right. So what do they ask? They ask to determine the mass fraction. How do you get the mass fraction? I will write it as MF. Mass fraction of what? Sodium hydroxide. Mass fraction of sodium hydroxide, how do you get that? Mass of sodium hydroxide divided by total mass. Right? Mass total. What is the mass of sodium hydroxide? 1.6 grams. What is the total mass? What is the total mass? 1.6 plus 1.2. That is 2.8 grams. Good. I think let us say 1.6 divided by 2.8. What did you get? What is the answer? Then you all have done this thing. You can write down the answer. I hope I'm not lagging now anymore. Right? What is the answer? 0.57. I told you that we will work for 2 decimal places. Harida? 2 decimal places, 571. You got a 57 kila appear. Right. And what is it? ppm value. How do you get the ppm value? ppm value is equal to mass fraction times 10 to the power 6. Ocharaini? ppm. You just take the mass fraction, convert it to ppm. So what is that? 0.57 10 to the power 6 ppm parts per million. ඒ කියන්නේ කොච්චරක්ද? 57 1 2 3 4 5. So that is your answer. බලන්න ඒක හරිද කියලා 1 2 no 1 2 3 4 5 6 නේද? නෑ 5යි එන්න ඕනේ. Right, let me erase that last one. 5.7 10 to the power 5. Right, ppm value is that. This is your ppm. Is it clear? Did you all understand that, Puda? Everybody? It is okay to give the scientific notation, no problem. Kisim prashna nahi, scientific notation is the most best way to the best way to report an answer. This kind of a large number, that is the best way. Alright? Again, no problem. 100% accurate. Alright? Okay. So I got 0.517. 517 nam varadi uda. 571 is the answer. But balanda apo double check karanda, you can divide and see. Right? Don't stuck with your answer. Double check, divide and see it. Mama varadi the 1.6 divided by 2.8. Yeah, 0.571. Right, okay. Is it clear? Puda, I'm waiting for you. Ah, yes, right, okay. Right, I'm waiting until you confirm this answer. The others are confirming, but I want you to get to the answer and we'll move on. Right, okay, very good. Right, let us look at the question number 3. Right, look at the question number 3. Read that question, will you? Ammonium sulfate is used as a fertilizer at the initial stage of the plant growth. Now, ammonia containing compounds, you need nitrogen for the growth of the plant. So they add the ammonium sulfate. Ammonium sulfate has a little bit of a higher weight than urea. Urea is the best fertilizer. Best fertilizer is urea, but then people use ammonium sulfate also. Right? In the initial stage of the plant growth, such a fertilizer bag weighs 50 kilograms. Now, there's a bag of fertilizer. This is the bag of fertilizer, and suddenly it became a circle. Let us say there's a bag of fertilizer like that. It contains nitrogen. Nitrogen, it contains 50%. 20% by mass. Nitrogen contains 50% by mass. The mass of a fertilizer bag is 50 kilograms. 50 kilograms is the mass of a fertilizer bag. Nitrogen mass percent, nitrogen, nitrogen mass percentage is 20. If 1 acre of land requires 400 kilograms, so you need 400 kilograms of nitrogen. Right? Determine the number of bags of fertilizer to be used in this land. So 1 acre, how many nitrogen, what is the amount of nitrogen that you need? 400 kilograms of nitrogen. Right? So 50 kilograms, how much of nitrogen do you have? So if the percentage is 20 divided by 100, if you have 100 kilograms, there is 20 kilograms of nitrogen. So one of these bags contain how much of nitrogen? Nitrogen in one bag. This is simple, but sometimes people have difficulty in getting this through. 50 make a divide by 2, divide by 10. And you are absolutely right. You have 10 kilograms of nitrogen in one of these bags. If you want 400 kilograms of nitrogen, how many bags do you need? 10 kilograms in one bag. Let's say bag is X number of bags, and you need to add 400 kilograms. So how many bags? So you need 40 bags you would need. Is it clear? What everybody understood this? Yeah. All right. Right. Let us do the next question. Put a venas. That is why I'm doing all the questions here. Like one question to the next question, it is slightly different. Right? Question number 4, Balanda. Right? Read the question 4. Read the question 4. You are provided with 20 milliliter aqueous sodium hydroxide having 0.08 grams per cubic centimeter with respect to sodium hydroxide. So you have, there's a solution. You are being given a solution. This solution has a volume of 20 milliliters. Make a volume, make a 20 milliliters. 20 milliliter solution. Inside this, inside this, there is sodium hydroxide. With respect to sodium hydroxide, it says there is 0.08 grams per cubic centimeter of sodium hydroxide. Now, this is not the density of the entire solution. This is the density of only sodium hydroxide. The unit is density in grams per cubic centimeter. Density of sodium hydroxide, it is less than 1. Normally aqueous solutions have a density 1 or more than 1. This is less than, very less than 1, right? So this tells you, if you take 1 milliliter of this solution, you have 0.08 grams. Did you understand what I'm trying to say here? In 1 cubic centimeter of that solution, you have 0.08 grams of sodium hydroxide. I'll write it in words just for you to understand this. Okay, shape ඔලුවට ගන්න 0.08 grams of sodium hydroxide NaOH in 1 milliliter. 1 milliliter. 1 milliliter is cubic centimeters. This was completely dissolved in water to form a solution of 100 milliliters. What you do is, you dissolve this to give you 100 milliliters of water. Final solution. Final solution is 100 milliliters. Calculate the mass to volume percentage of sodium hydroxide. Now, what they ask is, they want to calculate the mass to volume percentage. Volume. Percentage 100%. Right. What mass? Sodium hydroxide mass. So mass to volume percentage of sodium hydroxide. If there is any difficulty, you need to ask again, right? So what is the mass, total mass? Then you have taken 20 milliliters. Total mass of sodium hydroxide of NaOH. So how do you do that calculation? 0.08 moles are present in 1 liter. You have taken 20 milliliters. So what is the amount? 0.08 multiplied by 20 grams. This is the mass of sodium hydroxide. What 0.08 times 20 gives you 1.6 grams. 1.6 grams of sodium hydroxide is present. In this sample, there is 1.6 grams of sodium. Now that entire solution, entire sodium hydroxide solution is poured into this beaker, and you are making it to 100 milliliters. Mass of sodium hydroxide doesn't change, but the total volume changes. So what is the mass to volume ratio? Mass divided by volume and times 100%. Mass is equal to 1.6 grams. Can you tell me what is the volume? Now what is the volume? Is it still 20? No. Is it still 20? No, it's not 120. It says it's 100. Dissolve in water to form a solution of 100 milliliters. Final volume is 100. So 100 here. 100 milliliters. So multiply it by 100%. You don't write the unit. Make a unit mass to volume percentage. So what is that? 1.6% solution. Is it clear? 1.6% solution is that. Baland, I'll give you a second few minutes just to check whether you understood that. Right. Think, then they say calculate. I converted kilograms and එහෙම කරන්න එපා. ඉතින් එච්චර කරන්න එහෙම කරන්න නැහැ. Right? Grams per cubic centimeter. ඒකෙන් unit එක තියෙන. Calculate the volume of this solution required to form 20 milliliters of 0.2 weight to volume percentage sodium hydroxide. Alright? Weight to volume percentage. Right? Okay, so let us do that. So that's a little bit of a tough one. Calculate the volume of this solution to form 20 milliliters of 0.2 weight to volume sodium hydroxide. Right. Shouldn't the volume be 120 milliliters? Read the question, will you? It says completely dissolved in water to form a solution of 100 milliliters. Here it doesn't say that you are adding 100 milliliters. It says you're forming a solution of 100 milliliters. Did you understand that, Puta? Did you understand that? Grams and milliliters don't cancel out. This is how you give the volume percentage. Like, this is says mass to volume. No? So mass and the volume don't cancel. Only thing is we remove the unit and you give it as a percentage. Mass to volume percentage is 1.6. You don't cancel it. Haridhar, did you understand that? Right. Okay. Now let us look at the next one. Question number part 5. Part 5. Pay attention to this very well. Right. So you have this solution. You have this solution here. Right. You have this solution here. This one here is 1.6%. Again, 1.6 grams. 1.6 grams is present. No, 1.6 grams is present in 100 milliliters. That is what it means. Every 100 milliliter, you have 1.6 grams in 100 milliliter sodium hydroxide. This is the solution. Now, what do they want? They want to form. What do they want to form? They want to form 0.2 grams in 100 milliliters. Did you understand that? 0.2 grams in 100 milliliters. 0.2 weight to volume percentage. So weight to volume percentage means in every 100 milliliters, you have to have 0.2 grams. Did you understand that? Harideka, everybody understood that. So 0.2 grams in 100 milliliters. But you are making 20 milliliters. So make 20 milliliters. It says you are making 20 milliliters. Make 20 milliliters. And how much of grams should be there? How much of grams should be there? The mass of sodium hydroxide should be present. Should be present. Should be present. Here, how do you do that? Mass of sodium hydroxide that should be present. What is question? What is Q4? Q4 is kind of question hatara. Question number 4. Uda question again. Right? Question number, that is the question number 4 earlier. Is it clear? Sodium hydroxide that should be present. මට කියන්න බලන්න කොච්චරක් තියෙන්න ඕනද කියලා. So if you have 0.42 grams in 100 milliliters, හරිද? How many grams should be present in 20 milliliters? Right? 20 milliliters, 20 milliliters, 20 divided by 100 is 5 නේද? And that is equal to here the 0.04 grams should be present. ගන්න ඕනේ 0.04 grams of sodium hydroxide should be taken. එහෙම නේද? 100 you have 0.2, 20 milliliters you have to have 0.04. බලන්න whether you are okay with that. 100 milliliters you have 0.2 grams. In 20 milliliters you have to have a lower amount. How much lower? 1/5 of that material, 0.04. Well, Anik, those who give me those answers, double check and correct it. Put correct කරන්න මට. Resubmit the answer, will you? The others are okay. .2 grams in 100 milliliters, 20 milliliters, you have to have 0.04 grams. Right, Hari. So you need to get 0.04 grams. Now here it says in 100 milliliters, you have 1.6 grams. You have to take a certain volume. Now let us say that certain volume is V milliliters. This should be equal to 0.04 grams. So what is the volume that you have to take from the solution? What is the volume? 0.04 multiplied by 100 divided by 1.6 in milliliters. Kya denne? 0.04 times 100 divided by 1.6. You need to take 2.5 milliliters. So the solution that you prepare earlier, from that if you take 2.5 milliliters and dilute it to 100, you can use 25 milliliters. You can try any formula that you like. C1V1 is equal to C2V2. Anything you can use. Do the calculation. Right. Okay. Yeah. I think that's okay. Right. Everybody all right with that? Did you understand it? If you have the answer, then it's okay. You're like, there's no one method to get the answer. You can use any technique that you are comfortable, but you get the answer. Right? I am like, I'm explaining it to everyone. Right? So that is why. Right. Okay. Good. Right. Shall we do question number 6? Right. Work that out. Question number 6. See whether we can understand that. And acidic acid solution. What is acetic acid? CH3COOH. 1 to 25 weight to volume fraction. Again, mass divided by volume is equal to what is that? 1 to 25. Again, that means 1 gram in 25 milliliters. Right? It's given as a fraction. Right? Calculate the volume required to be measured to make 5 milliliters of 10% weight to volume acetic acid solution. So out of this, you need to make 5 milliliters of 10% weight to volume. I think always better to have the similar units. Then you can cancel out. So grams per cubic centimeter, let us convert this into the percentage. Right? Weight to volume percent is given. Let us look at the percentage. 1 divided by 25, 100%. Did you understand that? So what is the percentage? What is the percentage that you have? 100 divided by 25. What is the percentage? This is 4%. 4% solution. Now what do they ask? Calculate the volume required. You can use C1V1 is equal to C2V2. So what is that? So first solution is for 4%. The units are the same. And then take some volume V1 is equal to, you are making 5 milliliters of, what is that? 10% solution. So V1 should be, what is the value? 5 multiplied by 10 divided by 4. 50 divided by 4, what is that? 12.5. Because there is a mistake in it. What is the mistake? මේකේ mistake එක තමයි මොනවාද මේක I think like I miss the decimal place හරි මොනවා හරි එකක් පොඩි upset එකක් තියෙනවා 1.25 වගේ වෙන්න ඕනේ, right? Can you explain once again from the point where you got that 4%? ඉතින් මේකේ පුතා තියෙන්නේ weight to volume fraction නේ. Weight to volume fraction is given 1 to 25. If you want to get the percentage, how do you get the percentage? Multiplied by 100. Weight to volume percentage. Weight to volume fraction multiplied by 100% is equal to the percentage. Multiply by 100. Is it clear? හරිද? But there's a mistake. I think there's a 1.25 near 1 divided by 25. Right? Is the weight to volume percentage same as the concentration? It is not the same as the concentration. You know what do you mean by concentration? Concentration is moles per cubic decimeter. Usual practice to say concentration is moles per cubic decimeter. Usual practice is moles per cubic decimeter. But concentration means it's the strength of a solution. Strength of a solution can be given with various units. Percentage, fraction, mass fraction, volume fraction, molar fraction, all these moles per kilogram, moles per cubic decimeter is one of them, right? I think they are all given by concentration, right? All given the term concentration, meaning strength of the solution. How can we equalize C1 to 4%? C1 is a concentration. It's a concentration given as a percentage, right? Concentration given as a percentage, not moles per cubic decimeter. Did you understand that? It's not moles per cubic decimeter, concentration as given as a percentage, right? So that is why this unit is there. 4% කියලා තියෙන්නේ එකයි. It's not given as moles per cubic decimeter. Is it clear? Right. So here also the same unit, here also you have the same unit. Right. Okay. Now let us look at the part B. Part B, if the signals are interrupted, I suggest that you do this from here, this point onwards. If you can go back to and try to explain it again, we will never be able to go forward. Right. So I want you to this recording will be available in the website. I suggest you to look at it again. Right. If the signals are interrupted, even my signals becoming interrupted. So we will try to do that. B, part B. Question number 6, part B. Let's read that. Calculate the amount of sodium hydroxide in ppm. NaOH in ppm. in a mixture of 0.2 mole of sodium hydroxide. So here you have 0.2 moles of sodium hydroxide and then 0.4 moles of sodium. 0.4 moles of sodium. How do you calculate the amount of sodium hydroxide in ppm? Let's look at that. ppm means the best way to do is, if it is a solid sample, mass to mass ratio multiplied by 10 to the power 6. Mass fraction 10 to the power 6. So that's what I'm going to do, right? Let us calculate the mass of sodium hydroxide. Mass of sodium hydroxide is equal number of moles times molecular mass. They can hear the 0.2 times 40 grams. You can hear how much is that? 8 grams. Number of moles of sodium. Number of moles of sodium is equal again number of moles times, sorry, mass of sodium. Mass of sodium is number of moles times molecular mass, 0.4 times 23. Here then, 0.4 times 23. 0.4 times 23 is 9.2. Right, good. 9.2 grams. Now, what do they ask? They ask you to calculate the mass fraction of what? Calculate the amount of sodium hydroxide. So mass fraction of sodium hydroxide is equal to 8 grams. Divide by 8, 8, 16, 17.2 grams. Total mass is 17.2. Now you need to take it multiplied by 10 to the power 6. Then only you get the parts per million part. So grams and grams cancels out. 8 divided by 17.2 multiplied by 10 to the power 6. I will go for two, points. 4.65 kilenne. 4.65 10 to the power how much? 5 ppm kilenne. If you report it using SI units. Did you understand that? Did you all get that answer? Yeah, right. Very good. Very good. Well done. Okay. Right. Then shall we go to the next part? Next part is our question number six here. Not 6, the part take 7 the month. Yeah, question number 6, part 6. Right? Hari. Why when I asked you earlier, right? Question number, let us say it's C kila dagannu. C kila dagannu. Okay? Right. A sodium hydroxide solution has a concentration of 4000 ppm. Our concentration කියන එක don't අපි අර මෙහෙමනේ අපි like it's like this. It's like you're choosing a brand name. අර මොකද්ද ඔයාලට පළවෙනි ෆෝන් එක කිව්වහම what is the brand name that you will remember? ටක් ගාලා එන්නේ ඔළුවට එන්නේ. What is the brand name? කියන්න බලන්න. Now you all can. That is Gen Z අය නේද? Right? Gen Z අයට පුළුවන් නේ ටක් ගාලා ෆෝන් එකක් කිව්වම what is the brand name that you will come across? අර දැන් ගොඩක් අයට පේන්නේ මේ iPhone කියලා. iPhone කියලා තමයි ගොඩක් අයට පේන්නේ. හරිද? ඒක එක්කිනෙට දෙන්නට තියෙනවා වෙනස් like they have a different අර පොඩි මේකක් තියෙනවා. And then some people say Samsung. ඔය විදිහට. It's like a brand name. But then දැන් ඔය Apple කියලා දැන් මේකට කියන iPhone තමයි brand name. Samsung තමයි brand name. මෙහෙම කියලා කියනවානේ. But is that the only phone that is available in the world? නෑනේ. There are so many other brands that is there. But the first thing that will come to your mind is this. That is because you see this again and again and again. Right? People see that all over the place. You are seeing it and then it's a hardwire into your brain. So likewise, when you say concentration, first thing that will come to your mind is moles per cubic decimeter, because you keep on saying that for a long period of time. But it is not the only way to represent the concentration. Concentration can be represented with various units. Mara units ගොඩක් තියෙනවා. Percentage is a way of getting the concentration. හරිද? නේද? And then mole fraction is a way of getting the concentration. So likewise, there are kind of various ways of kind of reporting the concentration. So remember, the sodium hydroxide solution has a concentration of 400 ppm. 400 ppm means sodium hydroxide 400 ppm means what does it mean? 400 sorry, no, 400, 4000 ppm. 4000 ppm means you have the mass of sodium hydroxide divided by the total mass multiplied by 10 to the power 6 is equal to 4000. ඔන්න තමයි ඔය කියන්නේ. ppm. හරිද? Did you understand that? Only that is what it means. 4000 by mass and the total mass is 200 grams. එහෙනම් අපි කියන්න පුළුවන් mass of sodium hydroxide NaOH total mass they have given it as 200 grams. But the unit should be cancelled out. හරිද? 10 to the power 6 is equal to 4000. Then මෙතන මට දැන් somebody has sent me this මොකද්ද phone brand එක nothing phone කියලා එකක් කියලා දිනවා. I don't know, I have never heard that maker. Right? Have you heard something like that? ඔයාලා අහලා තියෙනවද එහෙම එකක්? nothing phone කියලා. I have never heard. අද තමයි අද පළවෙනිට ඇහුවේ. Yes, there's something there. Okay. There's a brand. දෙකනේ. අන්න ඒකයි. දැන් I haven't heard that brand. හරිද? දැන් ඔක මම අහලවත් නැහැ. But then that doesn't mean it doesn't exist, නේද? ඒ වගේ තමයි. So moles per cubic decimeter is not the moles per cubic decimeter is not the only thing that only way to report the concentration. There are other ways. One cubic, like tablet, medication. That's a way of expressing the concentration. It says milligrams. It way of expressing. A bottle of wine contains alcohol, it has a way of expressing the concentration. There's a way of expressing that. As a volume to volume ratio and 100%. So likewise, there are various ways to express concentration. Moles per cubic decimeter is the most frequently used. You will be using 95% of your lifetime. You might use concentration as this. A lifetime as a A-level student. You might use concentration moles per cubic decimeter. But that doesn't mean you can ignore the others. Other units you can't ignore. Then ppm is also another way of expressing it. So mass of sodium hydroxide, here the mass of sodium hydroxide is equal to 4000 multiplied by 200 grams divided by 10 to the power 6. If you go to 1, 2, 3, 4, 5, that will cancel out. So 4 times 2, 8. 8 divided by 10 is 0.8. On mass of sodium hydroxide in this sample is 0.8 grams. Calculate the number of moles of pure sodium hydroxide. How do you calculate the number of moles? Number of moles is equal mass divided by molecular mass. Children, balance 0.8 grams divided by 40. Balance molecular mass is 40 grams per moles. So that will give you 0.8 divided by 40. What is that? 0.8 divided by 40 is equal to 0.02. Then 0.02. And that is why. So remember, there are various ways of when you say concentration, and if they give you a unit, if they don't give you a unit, that is very upsetting. You have to make sure that it should give you what is the rule to determine this concentration. It is not always moles per cubic decimeter. If you ever buy a phone, okay, I bought a phone. Or let us say I bought a denim for the festival, a New Year. You can't. Like what is the famous brand for denims? Denim trousers. Yeah. I just okay, yeah, okay, right, fine. So that is it. The others? Yeah, ඔය විදිහට තියෙනවා. දැන් එක brands තියෙනවා, Levi's කියනවා, මොනවාද Moose කියනවා, L2K කියන. So like you have I have never heard these ones. OK කියනවා, CK කියනවා, එක එක කියනවා. So there are so many kind of different ways. So when you say that you bought a denim, you can't always say that, okay, that is a famous brand Dio hari මොනවා හරි එහෙම නැත්නම් එහෙම කියන්න බෑනේ අපිට. ආන් වගේ තමයි. So you need to see the brand name, then only you can realize, this is what he has bought, this is what she has bought. So likewise, in a concentration also, they have to report it using some kind of a unit. It can be weight to weight, fraction, weight to weight, percentage, moles per cubic decimeter, moles per kilogram. I hope I am getting this point to you, right? I think that is why units are very important. Otherwise, you don't have a clue. 4.8 kilowatt, you don't have a clue what it is. Is it moles per cubic decimeter? Is it percentage? Is it volume to volume percentage? Volume to volume fraction? We don't have a clue without the unit. The unit is very important. හරිද? I hope I got it through to you. Right? Excellent. හරි. එතකොට now if you are using, now I'm answering this original question somebody asked me, C1 V2 C2 V2, if you use some unit here, you have to use the same unit here. Now that unit doesn't need to be moles per cubic decimeter. This unit is a way of expressing the concentration, but this unit also should be the same. එහෙම නැත්නම් කරන්න බෑ. Right, okay. Right. Let us see. We will move on. But then whenever you have struggle, when you have any trouble, you need to ask this. Prashna, right? Okay, make sure to ask those questions. I will try my best to help you. Right. Without anything, like, එකම ප්‍රශ්නෙට අපිට ගිහිල්ලා කරනොත් අපිට ඉස්සරහට යන්න බැරි වෙනවා. You will discuss one question and then say, sir, we are tired කියලා කියයි. Question number 7. Read that question. Read that question, see whether you understand it. Okay. Okay, right. A certain volume of sodium hydroxide was mixed to form a solution of 80 milliliters. ඔන්න මොකද්දෝ solution එකක් තිබ්බලු. Right? There is a solution, some solution there. And volume was mixed to form. يعني මොනවද mix කරපුවාම you get a 80 milliliter solution now. This solution has a 80 milliliter volume. The concentration of the sodium hydroxide related to that volume, right? So let us say this is 80 milliliters. Is concentration milligrams per liter. Unit that means if you take 25 10 to the power 2 milligrams in 1 liter. In 1 liter, 25 10 to the power 2. What does it mean? It means if you take 1 liter of that solution, you have 80 milliliters, but 1 liter of this solution has 25 10 to the power 2 again 2500 milligrams thenol. That is what it means. Inside 1 liter, 2500 milligrams are present. The amount of sodium hydroxide in the aqueous solution is 0.08 grams per cubic centimeter. Density of water is this much. Right. Amount of sodium hydroxide in the aqueous solution is 0.08 grams per cubic centimeter. Right. Density of water is 1 gram per cubic centimeter. Calculate the number of moles of sodium hydroxide. Right. Calculate the number of moles of sodium hydroxide. How do you calculate the number of moles? Number of moles of sodium hydroxide කියලා කියන්නේ. Let us calculate how many milligrams are there. How many milligrams in this sample is there, right? So let us look at the mass of sodium hydroxide in 80 milliliters. How do you calculate that? How do you mean that? What do you mean by that? 2500 milligrams in 1000 milliliters. 1 liter they said 1 liter. So in 1000 milliliters, 2500 milligrams. Then in 80 milliliters, how much? So milliliters cancels out, 00 cancels out. This will cancel out and you get 25 multiplied by 80 milligrams thenol. 25 times 8 milligrams. Right. Then they ask you to calculate the number of moles. number of moles of sodium hydroxide, how much is that? Is equal to 25 times 8. Now, you can't keep milligrams, you have to convert it to grams. 10 to the power minus 3 grams. Divide by sodium hydroxide is 40 grams per moles. Go to sodium hydroxide, well, 40 Na, right? So, what is that? 25 times 8, 25 times 8, 10 to the power minus 3, divide by 40. Here then, 0.00005, 0.005 moles. Is it clear? Can you explain it again? හරිද? දැන් මේකේ කියනවා පුතා concentration of sodium hydroxide related to this volume is 25 10 to the power 2. ඒ කියන්නේ මොකද්ද? මේක නිකන් මේ milligrams per liter. That means in 1 liter එක ලීටර එක 2500 milligrams. There is 2500 milligrams in 1 liter. 1 liter of this solution 2500 and you have 80 milliliters. If you have 80 milliliters, can you tell me how many grams are there? How many grams are there? You can't use C is equal N divided by V because මේ කට්ටිය දීලා තියෙන milligrams per liter වලින්. Right? එතකොට you have to find the concentration. තව ගොඩක් දිගයි ඒක. Right? So look at this one. මේක පොඩ්ඩක් බලන්නකො පොඩි දෙයක් තියෙන්නේ මේකේ. Liter, 1 liter contains 2500 milligrams. Then 80 milliliters, how many grams do you have? 2500 in 1000 milliliters. So 80 milliliters contains 25 times 8 milligrams. So what is the number of moles? 25 times 8. මේකනේ තිබ්බේ. Milligrams in the, you have to convert it to 10 to the power minus 3. Divide by the molecular mass. That will give you number of moles. එච්චරයි. පොඩි දෙයක් තියෙන්නේ. හරිද ඒක? Clearද? Everybody understood that now? Right, okay. Is it clear? Right. Next one is calculate the mass fraction of sodium hydroxide and repeat it in ppm. Can't be used 0.08 grams per cubic centimeter. Calculate the moles of sodium hydroxide. Moles of sodium hydroxide, then you might have to multiply it by 80. එහෙම කරලා හදන්න ඕනේ. grams අරගෙන divide by 20. And I think you get two different answers, I think. එහෙම කරොත්. Right? Two different answers. Right? Okay. Part B, calculate the load. The amount of sodium hydroxide solution is 0.08 කියන එක අයින් කරන්න. ඒක වැඩක් නෑ. I think it's a wrong thing to write. ඒක cut off that. ඒක you don't need. There are some mistakes here and there. Right, okay. You calculate the mass fraction of sodium hydroxide and report it in ppm. කොහොමද කරන්නේ? Right? Let us see. Let us do that. Calculate the mass fraction of sodium hydroxide. So how do you calculate the mass? Mass of sodium hydroxide. How much is that? Mass of sodium hydroxide කොහොමද අපි හොයන්නේ? Forget about the amount of sodium hydroxide in the aqueous solution is 0.08 grams per cubic centimeter. Forget about that. 0.005 moles multiplied by what? 40 නේද? එතකොට එන්නේ කීයද? So this is the mass of this solution. 0.005 times 40. කියන්නේ කීයද? What is the answer? What is the answer? Can you tell me? What did you get? Point? point kiyada? Point 005 times 40. I didn't find this. 25 times 8 if you find it, you can substitute it. You get 0.2 grams. What is the total mass? Total mass density of water is 1 gram per cubic centimeter. එතකොට amount of sodium hydroxide, let us say it doesn't change the volume drastically. So what is the total mass? Total mass is density times volume. So roughly density is 1 gram per cubic centimeter. Volume is how much? 80 cubic centimeters. Total volume is 18, right? So cubic centimeter per cubic centimeter cancels out 80 grams. Now, mass fraction, how do you calculate the mass fraction? Mass fraction is equal to, what is that? 0.2 is the mass of sodium hydroxide. Total mass is 80. Right? But 80.2 කියලා ගන්න පුළුවන්, but then we consider that the total volume, total solution has 80. 1 gram per cubic centimeter. Right? So what do you get? Mass fraction. This will cancel out. 0.2 divided by 80 is value is 2.5 10 to the power minus 3. This is the mass fraction. What do they ask? They ask you to report it in ppm, in parts per million. How do you get the parts per million? 2.5 10 to the power minus 3 multiplied by what? 10 to the power 6. 2.5 10 to the power 3. ඔන්න ඔහොම එකක් තමයි. This is called ppm. Milligrams per liter is ppm. එච්චරයි. Milligrams per liter means ppm. This is mass fraction multiplied by 10 to the power 6 is the equation that we use. ppm calculation means you take the mass fraction, convert it to 10 to the power 6. Why did you take the total mass of water density? It should be mass of water. Yes. Total mass, like, this is a very small quantity, 0.005 times 40. The mass of sodium hydroxide is 0.2, whereas the total mass is 80. I mean, that's a very small quantity. It's not a large difference. Right? So if you want, you can say 80.2. You can say 80.2, but that doesn't make a drastic difference in the answer, because this is a dilute solution. Can you report the volumes in ppm? Yes, you can report the volumes also in ppm. Did you understand that? Yeah, okay. Right. So the value that is given, concentrated sodium hydroxide milligrams per liter, 25 10 to the power 2, you are getting the same answer, because milligrams per liter means ppm. Right. Okay, let us look at question number 8. See whether we can come up with an answer to this. So I'm going to do this very slowly. Right. Why did you get the density of 1 gram per cubic centimeter? Density of water. Water is what is there. Like, in that entire solution, you have 0.005 moles of sodium hydroxide. Entire solution is mainly of water. So it is roughly equal to the density of water. It doesn't make a big difference. Isn't that so? Right? So that is why, right? We took it as 1. Right, okay. Question number 8. Right. Question number 8. 1 liter of atmospheric gas contains units amaru like 1 liter of atmospheric gas contains 510 to the power minus 5 cubic centimeters of carbon monoxide. May not chemistry. Sometimes people find it difficult to convert the units. Chemistry in a way, right? 1 liter. This is 1 liter of the entire sample. And inside this, let us say, I will write this one here. This is carbon monoxide. Carbon monoxide gas is there. You have 510 to the power minus 5 cubic centimeters of carbon monoxide. Calculate the volume percentage and report it in ppm. Now, when you are calculating the volume percentage, you have to get the same units. If you don't get the same units, they won't cancel. Volume percentage, mass percentage. Right? So, how do you get the volume percentage? Volume fraction. Mama, I will do the volume fraction. Then it is easy. Volume fraction is volume of carbon monoxide divided by total volume. Now, the sample is 1 cubic decimeters. Carbon monoxide is cubic centimeters. How do you convert cubic centimeters into cubic decimeters? Cubic centimeters into cubic decimeter, cubic decimeters into, or let us say cubic centimeters into cubic decimeters. Because we wrote it in cubic decimeters. So how do you convert cubic centimeters into cubic decimeters? Meaning milliliters into liters. 10 to the power minus 3. So 5 10 to the power minus 5 times 10 to the power minus 3 cubic decimeters. This and this cancels out, you get the fraction. So what is the fraction? 5 10 to the power minus 8. Now no units because everything cancels out. Now they ask you, calculate the volume percentage. Volume percentage. Come on, the percentage one. 5 10 to the power minus 8. Now volume fraction is that multiplied by 100%. So you get it as a percentage. What is the answer? 5 10 to the power minus 6%. 5 10 to the power minus 6% is the volume percentage. That is called the volume percentage. Volume percentage. Try the next one. What is the next one? Next one says volume percentage and report it in ppm. Come the report current ppm. How do you look at volume fraction? Multiplied by 10 to the power 6 කියන. So what is that? 5 10 to the power minus 8 multiplied by 10 to the power 6. What is the amount in ppm? 5 10 to the power minus 2 ppm. I told you, if you want to report it in ppm, you use very low concentration. Low concentrations, not the largest concentrations that you have. You have tiny concentrations, you report it in ppm. So best answer is 0.05 ppm. I hope you got the answer. Maybe this ppm calculation, people find it little difficult. Not because they don't know chemistry. Unit conversion is little difficult. That's all. ඒකයි. ඒක පොඩ්ඩක් අපි හදාගමු. එතකොට we will be okay, right? පොඩි දේවල් තියෙන්නේ, චූටි දෙයක් තියෙන්නේ. Right. Anyway. Right. Shall we look at the part 2? It should be not 21. It's the second question කියන එක. ඔය තියෙන්නේ 8. Question number 2. I am very bad at putting numbers into the tutorial. හැමදාම වැරදෙනවා. හැම වෙලාවෙම ඒක අප්සෙට් වෙනවා. හරි. Now this one is a question. I hope you got the idea there, earlier one. Everybody, go. Okuma, everyone, please tell me. Tell me whether this is all right. Right, sure? No problem, ne? Right, okay. Right, let us do the second part. Xenon is a noble gas present in the atmosphere in small quantities. Atmosphere this atmosphere contains xenon, small quantities. හරිද? 8A is this. Hurry. So you have noble gas present in the atmosphere in small quantities. This amount is usually 0.076 ppm by volume. And මේ total volume එක ගත්තු. If you take the volume of xenon, divide by the total volume of xenon, it says 0.076 ppm, parts per million. Right? Okay, fine. ppm by volume. Calculate the volume of xenon in cubic deciliters in 1000 cubic kilometers of the atmospheric sample which is provided to you. Right? 1000 cubic kilometers. Then make a so let us work with cubic meters. Cubic meters, right? So what is this? This is 1000 cubic kilometers means what? Cubic kilometers means how much? 10 to the power 3. Cubic kilometers means 10 to the power 3 to the power 3. Kilo means 10 to the power 3. Cubic kilometers 10 to the power 3 to the power 3 cubic meters. Look at my sample size. Did you understand that? Over there, check whether you understood that part. ඔය නිකන් අර කම්මැලිකම මේ පොඩි ටෙක්ස්ට් මේකක්වත් දාන්න නැතුව chat එකේ මොනවද දාන්න නැති ඉන්න අයටත් කියන්නේ ඔක්කොම දාන්න පොඩ්ඩක් මේවා කරන්න. හරිද මේ නේද? එතකොට තමයි මට තේරෙන්නේ like you all have got it නැත්තම් yeah. Chemistry what is difficult but simplification තමයි පුතා. I think you will get the hang of it. ඉතින් අපි ඕක හැම වෙලාවෙම difficult කියලා කියන්නවත් එපා කිසිම දෙයකට. Don't even think. මොකද your brain start believing it. ඔයා කිව්වොත් ඔයාගේ brain එකට this is difficult කියලා it start believing it. ඉතින් එහෙම කරන්න එපා. Don't let it believe that it is difficult. ඔයා කියන්නේ මේක lazy කියලා. මේක පුළුවන් කරන්න පුළුවන්. මට කරන්න බැරි නම් කාටද පුළුවන් කියලා ඔයා කරන්න. එහෙමයි. right? හරිද? right. clear? ඉතින් අපිට ලේසි විදිහට අපි හරව ගමු. ඔයාට ලේසි නම් cubic kilometers if you want to keep cubic kilometers and do it, you do it. This is what but like people understand easily because this is something that we always use. Cubic meters. The xenon 0.076 ppm. What do you mean by ppm? ppm means what does it mean? ppm means the ppm කියලා කියන්නේ. If you take 1 liter, the milligrams per cubic decimeter is mass divided by volume. Right? ppm means milliliters in 1 liter, in volume to volume. This is what is meant by ppm, milliliters to 1 liter. Milliliters milliliters is 1000. Yeah, milliliters microliters. Microliters in 1 liter. Milliliters is 1000 pp. Right. ppm is what is that? Microliters in 1 liter. ඒකට තමයි 10 to the power 6 කියලා එන්නේ. Microliters in 1 liter. එතකොට ඔයා like if you want to convert it to cubic meters, let us try to do that. 0.076 10 to the power minus 6 liters present in 1 liter. Did you understand that? ඒක හරියද තේරුණාද? This is micro නේ. ඔන්න මම මාක් කරනවා මේක highlight කරනවා micro. Microliters means 10 to the power 6 liters. Micro means 10 to the power 6 නේද? minus 6. 10 to the power minus 6 liters in 1 liter of sample. Then how much do you have in the atmosphere? How much do you have in the atmosphere? What is the amount? How much? 1000 times 10 to the power 3 to the power 3. The cubic meters. ඔච්චරක් cubic meters තියෙනවා. Did you understand that? එතකොට කොච්චරක්ද දෙන්නේ? Right? 10 to the power 3 to the power 3 is 10 to the power 9. 9, 10, 11, 12. You are multiplying by 10 to the power 12. 10 to the power 12, 10 to the power minus 6. That is 10 to the power minus 6, 10 to the power plus 12, 10 to the power 6. එතකොට එනවා 0.076 multiplied by 10 to the power 6 liters in this sample කියලා එනවා. This is the liters. Say non-liters is this much. So how much of liters? 7.6 10 to the power 4 liters කියලා තමයි එන්නේ. What do they ask? They are calculate the volume in cubic decimeters. Cubic decimeters means liters. Cubic decimeters is liters. 7.6 10 to the power 4. එතකොට මගෙන් අහනවා this question, why did you take microliters? හරි. ppm means parts per million, in million parts. Million liters, how many liters are there? Right? ppm means that. ppm means that. ppm means you have microliters on this side, divide by liters. In 1 million liters, this amount, 0.076. 0.076 liters is present in 1 million liters. That is what you mean by ppm. So what is that? 0.076 10 to the power minus 6. Where 10 to the power minus 6 is called microliters. So that is why I took it as microliters. Isn't the answer comes in cubic meters? බලමු අපි cubic meters වලින් දෙන්නේ කියලා. නෑනේ පුතා අපි liters වලින් හැදුවේ මේ. Right? Yeah, so it is in cubic meters. Sorry. Liters and liters cancels out and then answer comes in cubic meters. Yeah, you're right. It comes in cubic meters. Cubic meters, not liters. Cubic meters. That is why you need to write the answers also in a proper unit. So this is cubic meters. What do they ask? They ask you to calculate it cubic decimeter. How do you convert cubic meters into cubic meters into liters? This was, I was explaining something there. That is why I cancelled it out. 7.6 10 to the power 4 cubic decimeters. How do you multiply? 10 to the power cubic meters to cubic meters to cubic decimeters, 10 to the power 3. So 7.6 10 to the power 7 cubic decimeters. Balanda, you understood that, or you want me to, if you want me to explain it again, I will explain. No problem, just you need to tell me. Balanda, check whether you understood that first. If you didn't understand it, I will explain. Can you explain it again? Right, okay. I will do this. Right? Right? So you have a atmospheric sample. Inside this you have xenon. Xenon, it says 0.076 ppm. 0.076 parts per million is there. Again, what do you mean by that? It means if you take 10 to the power 6 liters, you have 0.076 liters in the sample. As 10 to the power 6 means million liters of the atmospheric sample, you have 0.076 liters of xenon. ඒක තේරුණාද? Parts per million definition is that. Parts per million. In million parts, how many parts are there? Right. 10 to the power 6 liters, you have 0.076 liters. Then your atmospheric sample is how much? 1000 cubic kilometers. So 1000 kilometers means 10 to the power 3 cubic. And it gives you cubic meters. Is it clear? The megana is xenon in the atmosphere. Xenon in the atmosphere is that. What did you understand that part? If you didn't understand it, tell me. So I can break it again and I can explain. But whatever we do, we need to understand it now. Okay, heta karanna bෑ. Right? Tomorrow is always late. Then, this time. But I'll spend more time with you on this. Can go? Whether you understood this. Is it clear? 1000 liters, 1000 cubic kilometers. Cubic kilometers means kilometers cube. Okay, cubic kilometers. Kilometers means 10 to the power 3 meters. To the power 3. මේක නිකන් physics එකක් වගේ නිකන් දැන් වෙන්නේ. Physics අර units and dimensions වගේ scene එකක් තියෙන්නේ. Right? හරිද? ඊට පස්සේ what is that? 10 to the power 3 to the power 3 is 10 to the power 9. හයක් නෙවෙයි. Right? 10 to the power 3 multiplied by 10 to the power 3 multiplied by 10 to the power 3. 10 to the power 9 multiplied by 10 to the power 3, 10 to the power 12 ඔක්කොම. හරිද? Is it clear? So now we are going to get the xenon amount. What is that? 0.076 divided by 10 to the power 6 multiplied by 10 to the power 12. The unit is cubic meters. Liters and liters cancels out. And 10 to the power 6, 10 to the power 12 means 10 to the power 6. හරිද තේරුණාද? So what is the answer? Xenon 7.6 10 to the power 4 cubic meters. Is it clear? ඔය තමයි volume in cubic meters. Then xenon in cubic decimeters. කොහොමද ඒක හොයන්නේ? Cubic decimeters means 7.6 10 to the power 4 cubic meters to cubic decimeters. You have to multiply by 10 cubic decimeters to the power 3. What is that? 7.6 10 to the power 7 cubic decimeters or 7.6 10 to the power 7 liters. Balanda, check whether you understood that, at least now. If you want to, if you haven't understood that now, I will explain it again. තව පාරක් කියන්න. Is that okay? Everybody, anyone who didn't understand it? Sure, ne? Right, okay. එහෙමනම් අපි යන් question number 9. Let's go to the next page. Next page නෙමෙයි. The one that is there. හරි, right, good. ඔක තනියෙන් කරන්න දැන් right? It's a unit conversion thing that's happened. Right, හරි. Question number 9. No, sir, I have got the answer, but I have got written as 7.6 10 to the power. අනේ පුතා. මොනවද අනේ මේ කියන්නේ දරුවෝ? 76 10 to the power 6 is equal to 7.6 10 to the power 7. ඔය දෙකම එකයිනේ. එකම උත්තරේ. It's the same answer, right? Okay. හරි නේද? I'm glad that you got that answer. බොහොම හොඳයි. Very good. Well done. Well done. හරි? Right. Question number 9. බලන්න. Right. Let us focus on this. Right? You don't need a break නේ නේද? break එකක් ඕනේද? Do you need a break? Then. නෑනේ. You're okay නේ? Can manage. Right. තව ටිකක් කරමු. Question number 9. A mixture containing carbon dioxide and nitrogen occupy a volume of 1.12 milliliters at STP. There's a gaseous sample. It contains carbon dioxide is there. It contains nitrogen, right? And the volume occupied is 1.12 milliliters at STP, standard temperature and pressure. Don't worry. You are done on standard temperature. Can you all tell me what is the standard temperature? Money, right? Very quickly. Tell me what is the standard temperature for gases? Somebody is good, Sha, near my standard temperature. Temperature milliliters. Temperature is 0 degrees Celsius, not 0 Kelvin, 0 Celsius. Right? And what is the atmospheric pressure? Standard atmospheric pressure? 1 atm, right? Near my Sha. What is the molar volume? What is the molar volume at standard temperature and pressure? 22.4, 22.4 what? Liters per mole. Near my. Sha. Very good. Well done. Very good. Okay. If the volume percentage of nitrogen is 80%, then calculate the number of moles of carbon dioxide at STP. If the volume percentage of nitrogen is 80%, make a volume percentage 80% now. What is the volume percentage of carbon dioxide? What is the volume percentage of carbon dioxide? 20%. Right. Now, the number of now I know you know about ideal gases. Now, ideal gases, they don't have internal volume. So if they don't have internal volume, volume percentage is equal to molar percentage. Volume percentage is equal to molar percentage. If it is nitrogen is 80%, molar percentage is also 80 because now volume is proportional to the number of moles. You understand that whenever you pump a gas, when you pump more molecules, the volume become bigger. When you have less molecules, volume become lower. So volume and the number of moles are proportional to each other. So calculate the number of moles of carbon dioxide at STP. Let us look at the volume of carbon dioxide. Here the volume of carbon dioxide can balance. Volume of carbon dioxide is 1.12 times 20% divided by 100. Make 20% is carbon dioxide. Milliliters. Milliliters. What is that? 1.12 times 20 divided by 100. Did you understand that? 0.224 moles. Right? I think it is better to write it down. It is better to write it down in that tutorial in some corner, right? In a gaseous mixture, volume fraction is equal to molar fraction. Volume fraction is equal to molar fraction. Volume percentage is equal to molar percentage. Higher the volume, higher the number of moles. Lower the volume, lower the number of moles. 0.224 milliliters are there. What do they ask? Calculate the number of moles. How do you calculate the number of moles? Number of moles is equal volume divided by molar volume. That is how you calculate number of moles. 0.224 milliliters. Milliliters means, let us convert it to liters, 10 to the power minus 3 liters. Divide by molar volume. What is the molar volume? Molar volume is 22.4 liters per mole. I okay note එකක් දෙන්න නෑ. There's nothing to give. Can you please give a note? There's nothing to give it as a note. May higher the number of moles, higher the volume. Lower the number of moles, lower the volume. Again, volume is proportional to number of moles. Oh, copy gases. So, you think you don't have to. You don't need a note here. Note tab, note tab. Here a note, there a note, everywhere a note වෙනවා නේ. හරිද? එහෙම ඕනේ නැහැ. අපි නිකන් දැනට පොඩ්ඩක් ඔලුවට ගන්න එච්චරයි. 10 to the power minus 3 divide by 22.4. These are gases නේ. ඉතින් අපි ඒක gases වල කරනකොට like we have started already. මේ ඔක next week වගේ අපිට ලියා ගන්න පුළුවන්. Right? 10 to the power minus 5. හරි නේද? Everybody understood that? Is it clear? Right, nearby. Very good. Calculate the number of moles of nitrogen. Now you can calculate. What is the number of moles of nitrogen? Number of moles of nitrogen, volume of nitrogen is equal to 1.12 times 80 divided by 100. Milliliters. Right? So number of moles of nitrogen, what is that? Volume of nitrogen divided by molar volume. What is that answer? 1.12 times 0 cancels out, 8 divided by 10 multiplied by 10 to the power minus 3 liters. Unit take a unit conversion is a must. Divide by 22.4 liters per mole. Right, clear? What do you get? 1.12 times 8. 1.12 multiplied by 8 divided by 10, that multiplied by 110 to the power minus 3 divided by 22.4. What is the answer? You all have got it right. Very good. Well done. 410 to the power minus 5 moles. How shape? Right. What is the volume of nitrogen occupied at STP? Nitrogen occupied at STP? Very simple. 1.12 times 80 divided by 100. Can you hear the point? What is the answer? What is the volume of nitrogen occupied? Volume of nitrogen occupied at STP? 1.12 milliliters multiplied by 80 divided by 100. 0.896. 0.896 milliliters. Calculate the molar fraction of nitrogen. Hari lazy. Molar fraction of nitrogen. I don't know me lazy but there is a mama nikam product nikam make a explain 10 to the power 5 moles nitrogen. What is the total number of moles? What is the total number of moles? Here 410 to the power minus 5. May laser point here. There is 10 to the power minus 5. What is the total number? Total number is equal to 410 to the power minus 5. 510 to the power minus 5 is the total number. 10 to the power minus 5 moles. This will cancel out and 4 divided by 5 is equal to 0.8. The molar fraction is 0.8. This is 80%. 80 divided by 100. That also another way to get it. Molar fraction is equal to volume fraction. Molar fraction is equal to volume fraction. Straight away you can get it. We'll do this question and we'll stop for today. Now you are like you might be tired also. Question number 10. Whether we can do this. Question number 10. Right. Okay. You all tell me the answers. Then one answers only matter. Molar fraction of methane is 0.4. 6.4 grams of methane has been mixed with 14.4 grams of gaseous Y. You have how many? There's a gaseous Y. Gas. Methane, CH4, right? CH4 is also a gas. Molar fraction of methane is 0.4. Molar fraction. This molar fraction is methane is 0.4. Can you tell me what is the molar fraction of y? එහෙම කරපු ගමන් what is the molar fraction of y? And tell me the answers. I will not reveal the answer. ඔයාලා දානකම් ඉන්නවා මම දැන් උත්තර ටික. Right. කියන්න. Right. Everybody, come on, guys. Yes. And 1 minus 0.4 summation of molar fractions is equal to 1. So to 0.6. So right. Very good. එක හරිනේ. Right. ඊපස්සේ කියනවා 6.4 grams of methane has been mixed. එතකොට methane, the mass is 6.4 grams. Right? Y, what is Y? 14.4 grams. Grams of gaseous Y. Calculate the molecular mass of Y. හරි. අපි බලමු ඒක කොහොමද කරන්න කියලා. Right. Let us look at the number of moles of methane. Here the number of moles of methane is equal to mass divided by molecular mass. කියන්න බලන්න. What is the number of moles of methane? A mass is 6.4 grams. What is the molecular mass? 12 plus 14. 16 grams per moles. This is the number of moles. And 6.4 divided by 16. What is the answer? You all didn't tell me. Go. 6.4 grams is there. 16 is the molecular mass. What is the answer? 0 nang wenna 0.4. Very good. 0.4 moles are there. Calculate the molecular mass of Y. ඒකනේ අහන්නේ. Yeah. තාම උත්තරය ආවේ නැහැ. 0.4 moles. There are 0.4 moles. හරිද? Yes. I know. 0.4 moles are there. Right? තේරුණාද? Did you understand that? So, if you know the molar fraction of methane, what is the molar fraction of methane? Number of moles of methane divided by total number. Value is equal to, molar fraction is equal to 0.4. මේ දීලා තියෙනනේ 0.4 කියලා. Right? So that means number of moles of methane is 0.4. Now, what is the total number then? Is equal to 0.4. මේක කැපුවාම this cancels out. Total number of moles is equal to how much? 1 mole. Would you agree? මේක අස්සේ තියෙන total number of moles is 1. Is it clear? Right. Then can you tell me how many number of moles of Y is there? Out of 1, 0.4 you have to deduct. That means 0.6 moles are present. Agree the නැද්ද ඔකට? 0.6 moles are present. Now you know number of moles is equal mass divided by molecular mass. Number of moles is equal to 0.6. What is the mass? They have given 14.4 grams. Unit moles. Then what is the molecular mass? So molecular mass of Y is equal to 14.4 divided by 0.6. 14.4 divided by 0.6 is equal to 24 grams per moles. Molecular mass is equal to 24 grams per moles. Did you understand that? Did you understand that? 26 නම් වෙන්නේ 24 කියලා එන්න ඕනේ. Right. Okay. හරි. You all are yeah. Okay. Right. Good. ඒක හරිනේ. Then it says calculate the volume of Y at STP. බලන්න කොහොමද කරන්න කියලා. Number of moles, second part. Number of moles is equal volume divided by molar volume at STP. What is the volume? Volume is equal number of moles times molar volume. What is the number of moles? Number of moles of Y is 0.6 moles. What are the molar volume? 22.4 liters per moles. So per mole cancels out. 0.6 times 22.4. What is the answer that you get? 13.44 liters. 13.44 liters. Somebody asked me, why did I get 2.4 grams per mole? 2.4 grams nang enda ba. 2.4 grams is not even hydrogen. Hydrogen නම් දෙකයි. දෙකට වඩා චුට්ටක් වැඩි. ඒක වෙන්න බෑනේ. Can't be. There's something wrong in it. Double check. What a decimal place එකක කවුලක් වෙලා ඇත්තේ. Right? Okay. So never mind. But I like the fact that you attempted this. එහෙම වැරදිලා උත්තරෙන්න හරි වැරදෙන්න හරි. You attempted it. That's a first step for winning is losing it. නැතුව ඕක කරන්න බෑ. වැරදෙන්න එහෙම ඕනේනේ. It's okay. හරි බලන්න ඒක decimal place එක කොහේ හරි තැනක් තියෙන point ගානක් තියෙන. Calculate the molar percentage of y. So molar percentage. කොහොමද molar percentage ගන්නෙ? So how do you calculate that? What is the number of moles of molar percentage of y? What do they ask is y. So number of moles divided by total number of moles multiplied by 100. Okay? Well, that is what do you mean by molar percentage, Buddha. What is the number of moles? 0.6 moles. What is the total number of moles? What is the total number of moles? 1 mole. What is the percentage? 100%. Again, molar percentage is 60%. You got it? Calculate the mass percentage of y. Let us calculate the mass percentage. Right. So let us look at the mass of y. එක දීලා තියෙනවානේ. Mass of y is equal to how much? 14.4 grams. So mass of methane. මම මේ නිකන් ලියන්නේ හරිද? They are already given 6.4 grams. So what is the total mass? Just for everybody to understand, may total mass. What a කෙලින්ම total mass ගන්න පුළුවන්. Add them together. So 20.8. Now you can calculate the mass percentage. Percentage mass is equal to මොකක්ද y 14.4 divide by 20.8 100%. किया देने 14.4 divided by 20.8 multiplied by 100%. Right? 69, yes, 69.23, yes, 69.23 නේද 23%. බලන්න that is the answer I got. හරි පුතා. එහෙමනම් can we continue this? මෙතනින් එහාට පොඩ අනික් ටිකක් කරන්න. Right now we have done this. ඉතින් මම like I give you the next tutorial also, and next time I'll do like odd questions and කොමාරි අපි මේකේ තව ටිකක් ඉස්සරහට we will progress next time. And then preparing standard solutions. And I finished the whole tutorial. That's a මාර නියමයි. Good thing. Well done. ඒක ඉවර කරන්න ඕනේ. අන්න එහෙම තමයි තියෙන්නේ. So I will give you another tutorial. Then අපිට තියෙනවානේ like balancing equations. And then we will complete that. Next week tutorial එකක් නැති වෙයි. But hopefully week after next I'll give you a tutorial. Oh, this week we have classes. Yes. Pay Saturday class එකක් තියෙනවා. We have classes this week. Ammonium chloride contains polar covalent or non-polar covalent bonds. Sorry. ඒක බලමු පුතා. Ammonium chloride NH4 plus Cl minus. Somebody asked me this. But නිකන් අර residual questions වලට I'll give you some time. Ammonium chloride. Nitrogen, this is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen, and this is a dative bond that is there, plus, and this is Cl minus. So what you have here is an ionic bond. This is ionic. And inside this you have nitrogen is, what is the electronegativity of nitrogen? 3.0. Hydrogen is 2.1. So this is, every bond is polar covalent. This is a polar covalent. Individual bonds are polar covalent. But entire molecule, ammonium molecule is non-polar. Ammonium molecule is non-polar. right? So non-polar තමයි molecule එක. Actually it's not a molecule, it's an ion. Entire molecule is non-polar, but it is an ion, positive charge ion, that gives you an ionic bond. I hope I clarify your answer there. හරි. අපි පස්සේ වෙලාවක ඒක කතා කරමු, right? Okay? Yes. හරි. Right. Okay. Anything else? Anything else can be chemistry related දේවා. අන්න වෙන ඒවා නෙවෙයි. Not don't ask personal questions. මේ SiO2 is a polar molecule. It's not a molecule, පුතා. SiO2 is a subunit on a polymer. මෙහෙමනේ තියෙන්නේ SiO2. Can you remember we gave you this? මෙන්න මෙහෙම එකක් තියෙනවා. ඕම එකක් තියෙනවා. මෙහෙම I gave you this මේ drawing නේ. මතකද? මෙහෙම ඇඳලා අපි drawing එකක් දුන්නා. Right? So this one, like this one. මේ වගේ අපි drawing එකක් I gave you to ask you to draw this. This is how actually the molecules exist. මේ entire lattice exists. It's like that. පොඩ ඉන්න, right? So හරි ඉන්න. Okay, right. Slowly, yeah? Slowly. Right? So this is what you have. So this is your silicon, this is your silicon, this is your silicon, and in the middle you have oxygen. So this is not a molecule, this is actually a lattice. Entire thing is a lattice. So we don't call it a polar molecule. Polar. Electronegativity on the next one. Can I ask a redox question? Help I will always help. But just a minute. Can I ask a redox question? Now, sir, is SiO2 is a polar molecule? Answer is no, it's not a polar molecule, right? Electronegativity difference is 0.9. Then how is it polar covalent? I think electronegativity difference is 0.4. It should be greater than 0.4, right? 0.4, and this is X, 2.1. Between 2.1 and 0.4, it is polar covalent. Right. What is the oxidation number of CuNH3 4 plus 2? ඊළඟට තියෙන ප්‍රශ්නේ. CuNH3 plus 2 ඔන්න බලාගන්න. 4 plus 2. ඒකේ copper වල oxidation number එක. Right. Copper, let us say oxidation number is X. Ammonia is a molecule. Ammonia is a molecule කියලා කියන්නේ molecule oxidation number addition is 0. 0 times 4 is equal to 0. Is equal to charge of a molecule plus 2. X is equal to plus 2. Copper oxidation number is plus 2. හරිද? මොනවාද කියන්නේ ඊට පස්සේ? මට අනික කියනනම් තේරෙන්නේ නැහැ. IUPAC short note මොකක්ද කියන්නේ? What an IUPAC short note කියන්නේ මොකක්ද? I don't understand that. එතන කියනවා C3H7OH. Wait. You're typing too fast and then I will never be able to catch up with you. Can you explain nitrate NO2, N2O3, NO, N2O, electronegative nitrogen English? I'll try to explain it. Try and let us try to do that. That is also another question. I know that everybody has a lot of questions. Type because it will go up in the thread. I have very difficult level of getting it. දන්නව නේද? හරිද? ඉතින් පොඩ හිමීට කරන්න. when I answer and complete a sentence, you write it, type it, leave it. බලමු අපි ඊට පස්සේ මේක කරන්න. NO3 minus and then NO2 මොනවද ඊළඟට? N2O3 ඊට පස්සේ NO ඊට පස්සේ N2O. හරි. ඕකේ මට තියෙන ප්‍රශ්නේ තමයි පුතා, there's a problem with this. You need to give me the which atom are you talking about? Are you talking about the electronegativity of the central atom? I suppose electronegativity of central atom. Electronegativity of atoms depends on 5 factors. Position in the periodic table, hybridization, then the charge on the thing, then the oxidation number, then the other atoms surrounding it. 5 points. So NO3 minus, now these are all nitrogen, so don't look at the periodic table. So NO3 minus nitrogen, double bond oxygen, dative bond oxygen, and this oxygen here, plus and minus here, minus here. So මෙතන තියෙන oxidation hybridization is sp2. NO2 is also like that. So NO2, petana 1 electron plus and minus. So that is also sp2. N2O3, I will look at the symmetric structure. Okay, දෙකක් තියෙනවා. Let us say you are looking at the symmetric structure. Without N2O3, no one has, you have not mentioned whether it's a symmetric structure or asymmetric. Let us say symmetric structure. So a symmetric structure means sp2. NO, nitrogen monoxide, ඔහොම එන්නේ නේද? Nitrogen, no, not, there's no double bond. Nitrogen, 1, 2, 3, 1, 2, 1, 2, right? So here also it is sp2. If you go to nitrogen N2O, there are two two nitrogens. So you need to look at the central atom. Let us say central atom. This is also, this is sp. Out of these 5 molecules, this one has the highest electronegative character. So N2O is the highest. Because central atom has a sp hybridization, higher the S character, higher the electronegativity. ඊට පස්සේ බලන්න අපි the charges, whether there are charges. එතකොට ඔයාලට charge එක ගත්තොත් එහෙම there's a positive charge here, there's a positive charge here, there's a charge 0 here, there's a charge 0 here. Now don't look at sp. Sp is now we have classified it. Well, you look at the remaining ones. There are 2 species with positive charges, 2 species with 0 charge. Now you look at the oxidation number because you can't decide. So now look at the oxidation number. Oxidation number is plus 5. This is here the plus 5. What is the oxidation number? Here plus 4. What is the oxidation number? This is plus 3. This is plus 2. Now I think you can classify it. So higher the oxidation number, positive oxidation number, greater the electronegativity. Next one is NO3 minus. Charges higher. We get positive charge. So NO2, but it has a low oxidation number. Now the charges are 0, 0. Out of that, higher oxidation number is N2O3 and the other one is NO. ඔන්න ඕම තමයි මෙයාගේ electronegativity reducing order. හරි. ඊට පස්සේ my goodness. හරි. ඔයා දීලා තියෙනවා මාර අමාරු එකක් මට කරගන්න පුළුවන් වෙයිද නැහැ. I don't know. මේ කියලා තියෙනවා don't explain using by the oxidation number method. How do you do it using the half reaction method? හරි. මෙන්න මේම reaction එකක් දීලා තියෙනවා. මේක I think this is a question from the tutorial. C3H7OH ඔන්න බලන්න. Right? Then sodium dichromate දීලා තියෙනවා. මාර අමාරු එකක් ඒක. Cr2O7. ඊට පස්සේ they have given sulfuric also. නේද? H2SO4 ඕම තියෙනවා. And they say that it is oxidized to, it says arrowhead, chromium sulfate වලට හැදෙනවලු. Cr2SO4 thrice වලට හැදිලා තියෙනවා. හරිද? And then sodium sulfate water දීලා තියෙනවලු. Sodium sulfate, my goodness. Water දීලා තියෙනවලු. H2O. And other than that, they have given C3H5O2H. C3H5O2H කියලා තියෙනවලු. අර ඒ කොනේ තියෙන H එක I have written it here. Now children, this is what this our friend suggesting me to do. මෙන්න මේක මට balance කරලා දෙන්න කියලා කියනවා. Now usually what you do is you need to, if you are looking at a half reaction, right, you have to identify the species that has converted. එතකොට C3H7OH has turned to C3H5O2H. මෙයා තමයි මේ දෙන්න තමයි couple එක. Right? These are there, like, you know, you have C3H7OH, it has turned to C3H5O2H. How do you know? Because that is carbon, this is carbon. You can't get sodium out of carbon. So carbon-based materials. ඉතින් ඔයා මොකද කරන්නේ? C3H7OH කියලා ලියා ගන්න. On this side also you write C3H5O2H. So this is the conversion. ඕක තමයි first conversion. Now next one what you do is මේ මෙතන තියෙනනේ Cr2O7 2 minus. and it has turned into Cr2SO4 thrice. So these two are the ones that are interconnected. So you can say Cr2O7 2 minus. පස්සේ දාමු sodium. Sodium is a spectator and anyway. Cr plus 3 තමයි මෙයා එන්නේ. The charge is Cr plus 3. Emitter, right? Now let us try to balance it. Cr plus 3 in a sulfate you don't get from chromium. Right, okay. So now let us see 3 carbons here and 3 carbons here. Principal atom is balanced. What is the next thing to balance? Oxygen. How do you balance oxygen? O2. There is only one oxygen here. So you add one water molecule. Now oxygen is balanced. Now let us balance hydrogen. How do you balance hydrogen? 7 plus 1 is 8. 8 plus 2 is 10 hydrogens. And then 5 plus 1 is 6 hydrogens. So that means you need 4 H plus. 4 H plus means you need 4 electrons. Right. Chromium to balance. Chromium 2, multiply this by 2. Principal atom should be balanced. Add 7 water molecules. Oxygen to balance. 7 times 2, 14 H plus. 14 H plus. How many electrons? 14 minus 2, 12 electrons. 2 times 3, 6 electrons. So you need to have 6 electrons. Then if you want to cancel up the electrons, you multiply this by 2. Multiply this by here. 3. Add them together. So you get 3 water. 3 C3H7OH. 28 H plus. 2 Cr2O7 2 minus, giving you 3 C3H5O2H. 3 times 4, 12 H plus. 2 times 2, 4 chromium plus 3. 7 times 2, 14 H2O. Hari. Then we simplify karagamu, right? Now I multiplied this. So let us try to simplify it as much as possible. Right. Here 3 water is there. You have 14 water. So I am going to deduct this. And I will get 11 here. What 14 minus 3 is 11. Here you have 12 H plus. Metana 28 H plus. 12 H plus kila kiyane kochcharadda? 12 H plus 28 H plus. I will deduct 28 12. Making 12 adu karapuwama kiya denne? 16 H plus. Now you introduce those spectate ions. Meka mai online nathuwa man me panthi karala denna puluwan nan godak hondai. I will discuss this again. Meka ටිකක් අර online කරන්න කිව්වොත් අමාරුයි, right? So what you have is 3 C3H7OH. Sulfuric ne H plus denne. H plus is given by sulfuric. So 16 then you need 8 sulfuric. 8 times 2, 16. You have added 8 sulfates here. Write them in the corner. Potassium dichromate, you get it as sodium dichromate. Na2, not potassium, sodium dichromate. Cr2O7 2 minus. Not 2 minus also. 2 minus. Na2Cr2O7, sodium dichromate. So 2 times 2, 4 sodium was added here. 4 sodium, very poor. It was not there. Now it gives you. Now this one is not an anion, nothing happens, C3H5O2H. I'm sure this has bored you a lot. Then okay, right. Now what you have is chromium plus 3. Chromium should be balanced with sulfate. Sulfate, when it balances, it should be Cr2SO4 thrice. So there are 4 chromium now. There's 4 chromium. Cr2SO4 3, you have 2 of them. So you have to multiply this by 2. How many sulfates did we use? 2 times 3, 6. That means now you are left with 2 sulfates. Then the remaining part is 14 water. මේක මේ A14. ඊට පස්සේ look at the ones that we haven't used. Sodium and sulfate. It gives you sodium sulfate. Na2SO4 and this is 2. ඔන්න ඕක තමයි තියෙන්නේ. I did it a little faster. හැබැයි ඔයාලට අර ප්‍රශ්නේ අහලා උත්තරේ දෙනකන් බලන් ඉඳලා දුන්නා නම් තමයි හොඳ. It would have been better, right? හරි. If the electronic configuration ends with 4s2, 4p6 and 4d4, do we consider the valence electrons in the outermost sub-energy levels or energy levels? May 4p, 4s2, 4p6 and 4d4. ඒ කියන්නේ මොකද්ද? 4s2, 4p6, 4d. I think you are asking, referring to this question that I asked in the exam paper. එතකොට ඔතනදී මම ගත්තේ මේ 4d6 තමයි. Because I gave you only 5 lines to write the set of energy. Do we consider the valence electrons in the outermost sub-energy levels? This is the total valence electrons. Total valence කියලා කියන outermost energy level එකනේ. Up to which lesson would they ask in the provincial exam test? මොකද ඉස්කෝලේ teacher කිව්වේ නැද්ද මොනවත්? I think they will ask up to bonding, I think. හැබැයි සමහර school, I don't know, it depends on how much you have done නේද? Provincial exam එකක් නම් I think it'll come to bonding, right? Yeah, you have right. හරිද? මේක අපි කරන්නේ නේද? Known as the lattice. What is known as the lattice enthalpy? Lattice enthalpy. Enthalpy means energy. Enthalpy කියන්නේ energy. Lattice means you are forming a lattice. Whenever it forms ionic lattice, how do you look at this one? ඊට පස්සේ කියනවා, there's another question saying what is the increasing order of boiling points of the following? There he has given helium, he or she, methane, and CCl4, carbon tetrachloride, CBr4, and SiH4. Hari. Now, these are all non-polar molecules. ඔක්කොම non-polar, right? Now, non-polar molecule these are all non-polar molecules. If you have non-polar molecules, you look at the molecular weight, right? So, what is the molecular weight? Helium is 4 grams per moles. 12 plus 4, 16 නේද? Carbon tetrachloride. Carbon tetrachloride is 13.5 times 4 plus carbon is 12. එතකොට මෙයාගේ molecular mass එක මොකද්ද? 35.5 times 4 plus carbon 12. එතකොට 154 කියලා එනවා. එයාගේ molecular mass එක. Carbon tetrabromide 80 times 4 plus 12. 332. Silicon, I think මට හරියට මතක නැහැ silicon molecular weight එක. Can somebody tell me? I don't have a log periodic table there. එකක් ගාලා 20 වගේ ඇති මං හිතන්නේ. 20 plus 4 26 කියලා ගමුකෝ අපි. Right? Right? 26. කියලා ගමු ඔය විදිහට. Right? හරිද? තේරුණාද? So now look at the, you always look at 20 කීයද? 28 දෙන්නේ. 20 කීයද molecular weight එක? Carbon. 28. 28. Okay, sorry. 28 plus 4. Then 32. නේද? 32. ඔන්න ඔය විදිහට තමයි molecular weight එක එන්නේ. So helium has the lowest boiling point. Then comes CH4, methane. Then comes SiH4. Then comes CCl4. And then comes CBr. They're all that. Right? Yeah. Okay. Make a water කරන්න බෑ පුතා. You have asking me an organic chemistry question. ඒක organic වලදී තමයි ඔයාට IUPAC නමෙන් ලියන්න පුළුවන්. You can write the IUPAC name. This is not an inorganic compound. We have done only the inorganic nomenclature. හරිද? 80 nanometers wavelength belong to which EMR? ඒක ගන්න මෙහෙමයි. E is equal hc divided by lambda, right? When the lambda decreases, energy increases. ඔහොම නෙවෙන්නේ. When the lambda decreases, energy increases. So if you look at මොනවාද මේ visible region varies from 400 to 700 nanometers. So lambda 80 means, nanometers means, this is lower in wavelength. Lower in wavelength, that means higher in energy. Higher in energy. Higher in energy means it belongs to UV, right? UV region. 80 nanometers, it's not that high. මේ පොඩ්ඩක් නිකන් ලාවට මේක කරමු. හරිද? Right. I'll take it one last question. හරිද? එක last question එකක් ගන්න. එකම එකක්. අන්තිම එක, the next available question that is there. Right? What is that? You get NO4 3 minus, NO4 3 minus, NO2 minus, NOCl, and then NO2 plus, and NO plus. ඔහොම දීලා මට කියනවා arrange them in the increasing order of the bond length. NO4, so what I do is I normally draw that O minus, this is O minus, this is O minus, and this is O minus, plus. NO2 minus means NO2 here, like, negative charge here, this is a lone pair, NO2 minus. NOCl, now this is not a Chemeve එකක් නෙවෙයි, I'm just like, slowly helping people to understand what they have problem with. එතකොට like, if you feel sleepy and Gilan, okay, sleep, right? එහෙම ඉන්න ඕනේ නැහැ, but I'm just helping out some of these kids. They have otherwise there is no way to answer these questions also. NO2 plus means this. NO2 plus is this. And NO plus is this. ඔන්නෝම තමයි තියෙනවාට. එතකොට this is what you have is this is a triple bond. Bond order is 3. Here the bond order is 2. මෙයාගේ bond order is also 2. පොඩ්ඩක් දෙකක් වගේ යනවා. This is sp2 and this is also sp2. sp2 overlap එකක් තියෙනවා. මෙතන තියෙන්නේ sp2 overlap එකක්. Right. And this one is make it තියන්නේ like 1 2 3 bond order is 1.5. Here the bond order is 1. ඔච්චරයි. Now I think you can arrange them, right? Shortest one is NO plus, shortest. Then you look at the bond order 2. Here it is sp2, here it is sp2. sp is shorter. එහෙනම් NO2 plus is the next one. ඊට පස්සේ this one sp2. මේවා දීලා තියෙන්නේ ඒ order එකමයි. NOCl. ඊට පස්සේ next one is NO2 minus. And the longest one is NO4 3 minus. නේද? හරි. Okay. එච්චර තමයි ඉතින් නේද? Right, okay. So that is where we stop today, right? එතනින් නවත්තමු. නැත්නම් ඉතින් this is not going to ever end නේද? ඊට පස්සේ අපි මේක කර කර ඉඳී. Like, but then please මේ මොනාරි තියනවා නම් please ask this in the මේකෙදි තහන්න. Like, physical class එකේදී තහන්න. Because ඔය physical class එකේ ළමයි එළියට යන්නම සෑහෙන වෙලාවක් යනවා. So rather than queuing up, you can ask a question. I am available. නේ? හරි. Okay. Let's do that. හරිද? අනේ thank you. Right? All the best. Good night. හරිද? හොඳට කරන්න. Make sure to do the exam. බෙල්ලා term exam එක හොඳට කරන්න බලන්න ඕනේ. You need to write the term exam. හොඳට මතක තියාගන්න. Right? And we'll meet on Saturday and we'll do that. හරිද? හරි. Okay. Right පුතා. Bye bye. Good night. Right? Okay. Take care.